All right, let's dive right in. Today, we're all becoming data detectives. Our mission is to take a complete mess of raw numbers and turn it into a story that actually makes sense, all by using the power of statistical charts. So, let's get to our first case.
Okay, so here it is, our first crime scene, just a wall of numbers. What is this? Well, these are the number of days patients had to wait for a mental health appointment. I mean, just looking at it like this, it's just chaos, right? It tells you basically nothing. And that's exactly the kind of chaos we're here to solve.
So that's the big question, isn't it? How do we take this pile of clues and find the hidden patterns, the story that's buried in there? Well, it's time to get to work, because we are about to crack this case wide open. First things first, we've got to venture into what I call the data jungle. This is where we learn how to navigate all that raw, messy information and start to get it organized so we can actually do something useful with it.
So our first tool in the detective kit is the frequency table. Think of it like this. Instead of looking at every single number one by one, we start sorting them into organized evidence bags. We group them into classes or intervals, and then we just count. How many numbers fall into this bag, how many in that one? It's a simple first step to taming the chaos.
And bam, here's what that looks like. Instead of trying to make sense of 60 different ambulance transport mileages, we've just grouped them into 4 simple categories. And instantly, you see a pattern, right? 35 of them, the vast majority, were less than 20 miles. Just like that, the picture is already getting clearer.
Now, the frequency table is our main tool for getting organized, but it's not the only one. For a real quick first look, you might use what's called a stem and leaf display. It's faster, kind of like a rough sketch of the scene, and you don't lose any of the original numbers. But for our main investigation, we're going to build on that frequency table.
Okay, so we've organized our clues. Now for the really cool part, visualizing the evidence. In this section, we're going to turn those tables into pictures to finally see the patterns hiding inside.
And our key tool for this is the histogram. Now, to make this idea really stick, I want you to just think about a city skyline. Each building is like a bar in our chart, and the overall shape of that skyline tells you the story of the city. That's exactly what a histogram does for our data.
And you know what? Building 1 is actually pretty simple. You take the groups from your frequency table and put them on the bottom axis. Then you just draw a bar for each group up to its frequency count. The one key detail is that the bars have to touch each other. That shows the data is continuous, like time or distance. It's a direct translation of your table into a picture. And let's be clear, we're not just making histograms to create pretty pictures. The whole point is to see the distribution. That's the key word here. The distribution is the fundamental shape, the profile, the underlying pattern of our evidence. This is where the real aha moments are hiding.
And you'll find there are a few key profiles that you see over and over again. First up is the famous normal distribution. It's that classic, symmetrical, bell-shaped curve. Think about things like height or test scores. Most of the values are all clustered right there in the middle.
Then you've got the uniform distribution. If the normal curve is a mountain, this one's a flat plateau. All the bars are about the same height, which just means the values are spread out pretty evenly across the whole range. There's no central peak at all.
Now for these guys, skewed distributions. They kind of look like a slide at a playground, right? A great way to remember them is to look for where the data is light, or where the long tail is. If it's light on the left, it's skewed left. Light on the right, it's skewed right. Simple as that. And finally, the bimodal distribution. I just called this the camel chart, because, well, it has 2 humps. Now, when you see this, your data detective alarm bell should be going off. It's a huge clue that you probably have 2 totally different groups mixed together in your data, each with its own peak.
But look, a histogram isn't the only tool in our kit. You wouldn't use a hammer for every job, right? A good data detective needs different charts to tell different kinds of stories. So here's a quick field guide. If you want to see trends over time, you'll use a time series graph. If you want to compare quantities between different categories, like sales between different stores, a bar graph is your best friend. And if you want to show parts of a whole, like how a budget is sliced up, you'll reach for a pie chart.
Let's just take a closer look at the time series graph, because it is so powerful. Here, it's tracking flu-like illnesses week by week. You can see the seasonal rhythm, the normal ups and downs, and then, whoa, that massive spike right there tells you about a major outbreak. It's a story literally unfolding through time.
Okay, this brings us to what might be the most important part of our whole investigation, integrity. You see, a chart can bring clarity, but it can also be used to deceive. We have to learn how to spot a graph that's trying to mislead the jury.
Take a look at this bar chart. It shows the percent of people without health insurance.
But look at that vertical axis. It goes all the way up to 70%. Because of all that empty space, the bars look tiny, and the differences between them look pretty insignificant. The story this graph is telling is, nothing to see here, folks. Move along.
Now let's just adjust that axis to a more reasonable 35%, which is just above our highest data point. It is the exact same data, but now the bars look taller and the differences are a lot clearer. This is a much more honest way to present the information.
But what if someone wanted to be really dramatic? They could shrink the axis even more, making the top 30%. Suddenly the bars are huge. The gaps between them look like massive chasms. The same data is now telling a story of a shocking, dramatic problem. This is how charts can lie.
So here's the crucial takeaway. You have to, and I mean you have to, always check the axes. The scale of a graph isn't just a boring technical detail, it is the narrator of the story. By changing the scale, you can change the entire plot without ever touching the actual data.
So, the next time you see a chart, don't just accept the story it's telling you at face value. Put on your data detective hat, look at the shape, check the axes, and ask yourself, a graph is a story, for sure, but what story is it really telling me? That's the real key to turning chaos into clarity.